Welcome back, learners. In our previous session, we listened to Dr. Anjali Chandra, who told us in detail regarding the distribution planning. For the benefit of the learners who joined us late, let me introduce our experts again. We have Dr. Anjali Chandra from Central Electricity Authority, and with me we have Dr. K.K. Govil, former Director, Power Finance Corporation, and also Mr. V.S. Verma, Member Planning, Central Electricity Authority. In this session, Dr. Anjali Chandra will be discussing about the grid management, load scheduling and load balancing. So I now request Dr. Anjali Chandra to continue.
Thank you, Dr. Bhardwaj. In the last session we dealt with distribution planning. I would like to add a few words to what we did in the last session. Distribution planning is a very dynamic exercise. Though we plan for 5 years, we usually take a midterm review at 2 years or 2.5 years to see that the distribution system expansion is taking place, the load growth is taking place according to what we had envisaged. Sometimes the load growth does not take place according to what was envisaged at the time of planning. This may be due to change of policy of the government, change in government, or some other tax benefit given in some other area, a tax holiday given in some other area. So the industry shifts to that area. So whenever we are doing distribution planning, we should always take a midterm review and find out that the load growth has been as it was expected, and then review our distribution plans, seeing what has been in the load growth in each area, and move for the next 2.5 years, considering the changes which have taken place in the past 2.5 years. Secondly, I mentioned about the GIS substation. GIS substation generally means a gas insulated substation, which means insulation of the switchgear and other equipment in SF6. This was earlier being done at high voltage level, and we have a gas insulated substation in Delhi on Park Street, which is of 220 kV level. But now we are having GIS substations even at 33 kV level, and these, I saw one of these substations which has been made by CESC in Calcutta. These substations are very compact because the switchgear and other equipment is enclosed in gas, and it takes 1/3 of the space of an ordinary outdoor switchyard. So that is why we can go in for these GIS, especially in metro areas where land availability is difficult, and we can go with GIS underground also. So 33 by 11 kV substation can be constructed underground also with the help of gas insulated substation. This is what I would like to tell you. Further, we move on to grid management, load scheduling and load balancing. So as we know, the supply chain consists of the generation, the transmission and the local distribution system. Grid management generally refers to the transmission portion of the chain, that is between the generation and the distribution. Grid is defined in the Electricity Act 2003 as the high voltage backbone system of interconnected transmission lines, substations and generating plants. This interconnected system with thousands of kilometers of lines and hundreds of generators, these operate with split-second synchronism. A grid is a system in which all the transmission lines and generators operate in synchronism, and it is the greatest scientific achievement of the millennium. And the largest single machine, it works as a single machine, all the grid and the transmission lines as well as the generators. That is one of our biggest achievements in this millennium.
I think
yes.
It requires to be, learners should know that why we are calling it a grid system and transmission system backbone. You know, the generation of electricity can be in many ways. It can be from a thermal station, it can be from a nuclear station, it can be from a hydro station. And these stations are located depending on the resources availability for power generation. So they are located at different points depending on the generation potential available. and where the stations have been located. Now this generated electricity has to reach the places where people live, and therefore a distribution system is connected to the people who are using this electricity. So between these generating stations where we are generating bulk of electricity and the places where we have to consume, which are called load centers in a normal parlance. A city is a load center, a district is a load center, and a village substation may be a load center. So the normally transmission system is called 132 kilovolt voltage to any highest voltage. In India we are having up to say 765 kV, kilovolts. So between the generating station and these distribution stations, we create a network so that we can reach electricity from any generating station to any place as far as possible. So this is about the subject. This is called grid, through which we reach, just like national highway we call to reach from one place to the other. In the transmission system, we are reaching through these voltages, high voltage transmission system between the generating stations and the consumption centers. So Dr. Chandra can continue.
Well, earlier we used to have the localized generation and the local transmission system in the 1950s. But later on, when it was found that the generating stations may be at, say, the hydro resources, as explained by Dr. Govil, are in the Himalayas. They may be in Arunachal Pradesh, they may be in J&K, they may be in Himachal Pradesh. The coal generating or thermal power stations are maybe in Bihar, where the coal mines are there, in Odisha and in UP. So we need to take power to the place where it is required. The generating station may be very far off. So we thought in 1960s of having a state grid, then in 1970s of having a regional grid where all the states in a region were interconnected, and finally we are moving towards a national grid from 1990s onwards, where all the transmission systems in the country are to be connected, and it is envisaged that in the future all the entire regional grids will be interconnected, because there are surplus generating regions and there are deficit regions, and we need to take power from the surplus generating regions to the deficit generating regions. So,
may I little supplement to the learners? Learners should know that earlier, at the time of independence, we had generating stations, and then the local distribution system, local transmission was available. Then we thought of the regional grid. When regional grid became a bigger system of the transmission system, and the whole country was divided into 5 regional grids: northern grid, western grid, southern grid, and eastern grid, and then for the northeastern region, northeastern grid. Now all these grids were operating independently with very little interconnection available amongst each other, and the frequency of operation of these grids were entirely different, each grid operating a different frequency. The problem which occurred due to the regional grid is that in one of the regions the country's resources are available. The eastern grid, mostly the coal resources are available, so the most generation is possible in the eastern region, and therefore if the region remains as a region, then the problem comes that the electricity generated in that region cannot be absorbed in that region. But then, due to the commercial reasons, we developed a system of the state generators and the central generators. The state generators do generate electricity, and the consumption is there in the state, and the state buys power from the central generators. And there was a commercial arrangement evolved between the two. The problem became, because of the commercial reasons, everyone wants to generate, because the central generator wants to sell electricity to the state sector, and the state generator they do not want to buy power from the central generator because the demand is not there and which they have to pay. So the problem which occurred is that the the frequency in some of the regions became very high beyond the acceptable limits, and the need arose that the power generated in that region must be transferred to another region which is a deficit region, and therefore the demand for interconnection of the regions. This interconnection, when it spreads from one grid to another grid, ultimately results into a national grid. The national grid has an advantage of total reduction of the generation requirements in the country, because the peak requirement in a region occurs at different time. So if we exist in the 5 regions, then it means we have to generate electricity equal to the total peak demand of one region, total peak demand of another region, plus another peak, plus another peak. This total sum requirement becomes very high, and the peak requirement occurring at different point of time in different regions. And if there is a national grid interconnection, then perhaps we can reduce the total requirement, because at one point of time there is a requirement here, there is a generation available at another place, so this generation could be transferred to another region, and the country's total requirement of generation comes down. And now we are planning for a national grid in the country. The 4 regions in the country are already interconnected. Only the southern region needs to be connected. We will connect it at appropriate time. Madam Chandra will now explain to you how do we proceed further. Thank you.
Well, thank you, sir. So the objectives of grid operation are that we should be able to operate the grid with reliability, with security, economy, and quality. I'll explain each of these now. Reliability. With the operation of the grid, the system is more reliable, since we can serve the load in more than one way. We have alternative paths. We have many generators and many transmission lines, so we can use one transmission line when the other transmission line fails. As a result, even if one generating unit fails, the rest can share its load. If we don't have a grid, then we will not be able to serve the load from alternative paths and alternative generators. Reliability comes with integrated grid operation, smooth evacuation of power, and delivery at the straits periphery. Then stability and security. The system becomes more stable as the chances of a fault disturbing the whole system becomes less. Security comes by maintaining the system parameters like frequency, bus voltages, line loadings, and transformer loadings within the permissible limits. Economy. In a grid, the cost required is lesser than a dedicated system, since lesser installed capacity is required as well as lesser spinning reserve is involved. If we were to have installed capacity for each group of loads separately, then the additional capacity required would be much larger than if we have an interconnected system and we can use the capacity available at other generating stations for feeding the load. Similarly, we require lesser spinning reserve if we have an interconnected grid system. Economy comes by merit order generation. That means merit order generation and dispatch. All the generating units do not generate at the same cost. Each generating unit has its own cost of generation, and the cost at which it is supplying to the grid varies. So we, in a grid, we can ensure that the generating units which generate at less cost, they are operated first, and if there is a requirement, then only the other units which generate at a higher cost are used. And this.
Yeah, Dr. Govil want to add something?
You see, the cost of generation, when we talk here, mostly it is the transportation cost of the coal or fuel to the station. Now, as you may be knowing that a thermal generating station uses coal as a fuel for generating power, and this fuel may be available. Some of these stations are called mine mouth power stations, which means that they are located just at the side of the very near to the mine. Other stations like which are located near the cities, as you know, the Indraprastha power station in Delhi, or Hardwaganj Power Station in UP, near Aligarh. These stations are very near to the cities, near the load centers, but they have to transport coal from long distances. So long as our grid system is strong enough to reach any load center from any of the generating stations, there is no problem in shutting down a unit if that much load is not required. So when the load goes down or total load goes up on the grid system, then if it goes up, we have to add the generating station. If it goes down, we have to shut down some of these stations or reduce the load on some of these stations. So the stations on which coal is coming from long distances, there the transportation cost becomes almost as much as the fuel mining cost. So our cost of generation can be reduced if we use the generating stations which are transporting coal from a shorter distances. This is just for the learners to understand that how this cost is increasing or decreasing. Thank you. Please go ahead.
So as explained, we can have a merit order dispatch where we use the stations which are near the pit head or coal mines first, and then use stations which are away from the pit heads. Then we can have optimization of hydro resources. The hydro resources generation varies with the season, and they may not be generating in winter but may be generating in summer, so we need to optimize the use of our hydro resources. We will have minimization of losses with interconnected grid, and we'll have judicious interregional exchanges which are required when there is a shortage of power.
I think, Madam Anjali, it is necessary to explain to the learners that why do we need to optimize the hydro resource or a mix of generation in the system. We have thermal generation. Dr. Govil said that there is a coal-fired. Then we have hydro generation, which are located in the remote areas, in the Himalayas, and this power has to be transported. Now there is a nature of a load curve in a system. That if we start in the morning, or say 0 hour in the early start of the day, then the load will start increasing when the people start getting up in the morning, 6 o'clock, switch on the lights and geysers, etc., and then they go for work. So there is a load pattern always. There is a peak demand and there is a off-peak demand, the base load in the system. Sometimes it so happens that the ratio of peak to off-peak demand is such that you have to commission your stations. That hydro station is that to meet the peak top requirement, you have to inject power into the system, and the rest of the base load requirement is met by a different source of generation. It was happening in one of the system, the say eastern region in the year 1997-98. Eastern region is predominantly thermal generation, and some small hydro is also there. Now it was surplus in the as far as the electricity generation or the installed capacity of the power generating system is concerned. It was surplus in the whole of the country, but still there used to be load shedding. Now people used to wonder that you have so much of generation capacity, but why do you do load shedding? This load shedding was in the area in the region was a technical requirement. The technical requirement was like that. I will explain that. The eastern region was not very highly industrialized area, and therefore the most of the demand was the domestic demand, and therefore the peak demand and off-peak demand, it used to be a larger difference. If the peak is 100, the off-peak was only 50. The thermal generating stations have a peculiar characteristics that you cannot bring down the generation on these stations below something like 70% of their rated capacity, because if you bring down generation from below 70%, then there is a requirement of firing the liquid fuel like oil, diesel oil or the furnace oil, which is very expensive. People would not like to make the power unnecessarily expensive. So what do? That when the lean period comes, off-peak period, they better prefer to shut down a unit and rather than bringing down the generation below the minimum requirement. And therefore, when the peak requirement comes, then these units which are already shut down, it is not possible to bring back these units. Only hydropower supplement is possible. Therefore, the hydropower plus this minimum thermal power, it falls short of the peak requirement, and then there is a load shedding. So it's so difficult it was to explain that why there is a load shedding. So it is always a requirement that you must, any distribution company must get the power, must buy power from such resources which is very optimal, and they are able to meet their peak and off-peak period. Anjali, you can continue.
The major activities in grid management are demand estimation, scheduling and dispatch, real-time system operation, supervision and control of system parameters, network security and outage planning. We'll go into all of these. First, the grid demand should be able to meet the quality parameters, which are frequency, harmonics and voltage. As we discussed earlier, the voltage has to be maintained within certain limits as prescribed under the IE rules. In respect of frequency, it is a global phenomena. It is same at all points in a synchronous operation. So if the regional grid is interconnected, then the frequency at all points in the grid in the region will be the same. And the frequency is an indication of the balance between load and generation. So the frequency, if the load is more and the generation is less, then the frequency dips below 50 Hertz. And if the generation is more and load is less, then the frequency will go up above 50 Hertz. So in a grid operation, we have to maintain the frequency nearer to 50 Hertz. Low frequency adversely affects the performance of equipment. Lower frequency results in lower speed, lower output and lower efficiency of industrial and agricultural drives. So we should try to maintain the frequency of the desired level, and the band of frequency which has been prescribed under IE rules is that the AC frequency should not vary from the declared frequency by more than 3%. The power frequency variation permissible is 50 plus minus 1.5 Hertz. So to maintain this band, we have to have a load and generation balance.
We also explain here that why do we have a frequency band. One can always question that, let the frequency vary, how does it affect? I mean, why do we trip the generating machines if the frequency goes beyond a permissible value? So it has two parameters to it. One is that there is an appliance consuming electricity. There are electronics equipment, electronics based equipment. So they are very sensitive to frequency. So if the frequency is not within the permissible range, these equipment can get damaged. This is number one. Number two, if the frequency varies beyond a certain limits and it goes out either on the plus side or on the minus side, it does affect the generating units. The thermal generation is the boiler generates a steam, the coal is fired in the boiler generates a steam, the steam runs a turbine has its blade. These blades have got the aerodynamic design, and this steam strikes these blades at a particular angle. If the blade shape is like this, so the steam has to glide through it so that there are no jerks. Now when the frequency varies in the system, the speed of the turbine it changes, and when it changes, the steam direction changes when it strikes the blade. So the steam starts striking the blade at the reverse end, and this gives so much of thrust to the blades, it creates undue vibrations in the blades. The blades can break if you are operating beyond the frequency range. Therefore, manufacturer recommends that beyond a certain range, you must trip the machine. You must not run. So those generators who will not have a proper understanding of the system, they are likely to damage their machines. It happened in the eastern region when the frequency used to cross 52 Hertz many times. It was a race kind of thing, that who would generate more. And in this process, they damaged their lot of machine, and it was inspected and found that their blades have cracked, their rotors got cracked. And therefore, it has a very damaging effect on the generating machines. It has a damaging effect on the user appliances. Therefore, it is necessary that you must maintain the frequency within a certain range. The preferred range is that there should not be variation. Why should there be a variation? Your system should become so stable, it must be very reliable. You must have the generation and load balance, a perfect balance between generation load. But this can happen only when your system is properly designed, your distribution system is okay, your generation system is okay, and you are able to meet the demand of electricity as is required.
In addition to the maintenance of frequency within the desired range, we have also to maintain the voltage within the desired range, as discussed earlier. The voltage is a local phenomena. Whereas frequency remains the same, voltage varies at different points in the grid. The grid operator has to ensure that voltage is maintained at all points in the grid. If voltage is low or high, then capacitors and reactors are installed, and these are generally of the switch type, so that voltage is maintained within the desired levels at all points in the grid. Because low voltage would mean higher losses in the system, and it would also damage the equipments. The standard voltage variations we have already discussed earlier, plus 6% and minus 6% in case of low voltage, and in case of high voltage, plus 6% and minus 9%. Then the third parameter of quality which has to be maintained in the grid is the harmonics. The earlier harmonics were not playing a major role, but with the advent of electronic equipment and AC-DC converters and electric arc furnaces, harmonics are being injected into the system, and therefore the harmonics, the quality of power supply is affected by the harmonics. Harmonics basically is a multiple of the fundamental frequency that exists in a power system due to non-linear device operation. Generally we have linear devices, but all the computers and electronic equipment, thyristors, etc. or non-linear devices which cause a variation in the waveform of the power supply. Harmonics are a recurring distortion of the waveform and caused by various devices like frequency drives and non-linear power supplies, electronic ballasts, etc. So the waveform, instead of being of a pure sinusoidal type, will look like this, the current as well as the voltage waveform. The harmonics distort the current waveform as well as the voltage waveform, and it will look like what is shown in the figure. The amount of distortion will depend on the type of harmonic injected. The harmonics may be even or odd. The odd harmonics are like third, fifth, seventh, and so on, and even harmonics are second, fourth, and so on. So the type of harmonics will distort. The distortion will depend on the type of harmonics injected. And up till now we had no limitations on the harmonics which a consumer could inject into the system. But with harmonics, now we have standards for containing the harmonics. But first I would like to tell you about the implications of harmonics. Why are we thinking of putting standards on the limits of harmonics? It is because harmonics cause increase in currents, increase in T&D and equipment lost, and therefore blocked capacity and higher investment in generating capacity, then overheating and loss of life of equipment. They also cause equipment failure and malfunction. When there's a sudden equipment failure or a brownout, or you suddenly see that your tube light has fused, that may be due to harmonics. Then poor quality of production. What you had envisaged, whatever quality, the parameters vary because of change in the waveform of the electricity supplied during production. So the limits of being imposed on the harmonics, earliest limits were imposed in the CBIP report number 251, wherein the total harmonic distortion limit was 9% in systems which were below 45 kV. Now we are specifying these harmonic grid connectivity standards, which are likely, as I told you yesterday also, which are likely to be notified very soon. These limits of harmonics are also being specified by the Electricity Regulatory Commissions, and one of these I have indicated as specified by the Electricity Regulatory Commission of Andhra Pradesh. The cumulative total harmonic distortion at the point of commencement of supply for each consumer connected at 33 kV shall be limited to 8%. The cumulative total harmonic distortion at the point of commencement of supply for each consumer connected at 11 kV shall be limited to 8% as per their grid code. So this type of standards are also being specified by the Electricity Regulatory Commissions, so that the quality of supply in the grid is maintained with respect to the harmonic content.
This 8%, madam, this actually how for our learner friends, can you slightly give an elaboration of that?
Yeah, the total harmonic distortion is calculated for all the harmonics. For example, the odd and the even harmonics, the distortion caused by each harmonic is added and to arrive at the total harmonic distortion. And that should not be more than 8% of the waveform.
But that will be visible only in the form of a waveform, isn't it?
In the waveform.
And in the normal waveform versus the actual waveform.
Yeah,
which is
what I had indicated earlier, if you see this.
The total variation between these two.
Between the sine wave and the wave caused,
Yeah.
actually supplied due to the harmonics.
Exactly. So this is depending on the amplitude of the
Amplitude
of the waveform. Right. Go ahead.
So grid management, as the term implies, is managing of the grid. And what does it consist of? It consists of online real-time operation and offline operational planning. When you manage the grid, you have to look after two things. One is the online real-time operation. What happens in real time when some generator goes off, some line load lessens, there is a throw-off of the load. So various real-time operations affect the management of the grid. And one is the offline operational planning, actually what will be the generation and what will be the load in the coming, say, for next day, and we'll come to that. So, online real-time operation is done by the load dispatch centers, and as explained by Mr. Verma, we have 5 regional grids, and at each region we have the load dispatch center, which are known as the northern region load dispatch center, the southern region load dispatch center, the eastern region load dispatch center, the western region load dispatch center, and the northeastern region load dispatch center. So they look after the real-time operation of the grid.
Why, madam, these are called load centers?
Load dispatch centers.
Load dispatch centers.
Yes,
Why
because
they are called load dispatch centers?
They schedule.
For our learner friends, kindly explain that a little bit.
They are called load dispatch centers because they see which generation, which transmission line is to be put on, which is to be put off, or which generator is to be put into the system to supply the power. So they do the load dispatching, they do the scheduling of the generation as well as the load. That is why they are called load dispatch centers.
You should also explain to the learners that the system, as I think I covered a little bit, that we have the central generators and we have the state generators. Now the role of the central generator is to generate electricity and sell it to the states. The role of the state generators is to generate for themselves and distribute it in their own area. Now of course the system is slightly changing because of the liberalization of this. Anyone can sell to anybody if they have the surplus power. The management of the state is within the state, and the state load dispatch center controls that. It controls all generating stations in that state and where the electricity has to go, which are the transmission lines, how the frequency is controlled. And then there is to control the operation of the central generator versus the state generator, and how much electricity one has to buy from the central generator. What would be the generation from the state center generating stations? There is a need for what is called the Northern Region Load Dispatch Center and the Western Region Load Dispatch Center. They control and regulate the generation of the state generators as well as the power flow from the central generators, and they control a region. The region would be controlled, a dispatch, there would be a schedule initially given that how much the state generator has to generate, how much power they have to buy from the central generator, and then the whole lot of system management is done through these load dispatch centers.
Thank you, sir.
And to add to what Mr. Verma explained, if you see what is grid operation, in the grid, any change in the load power consumption, that is any large demand, some factory is working, it may shut down. Some houses we may switch on the bulb or switch off the bulb, so power will change. One of these stations, there may be some problem. There is a leakage in the of steam in a thermal plant, so the plant has to be shut down. Now all these situations have to be catered to. That is what is called online grid management. So it is in this situation that the national load center is basically controlling the central generation and the national grid, and the state load dispatch centers are controlling the state's generating capacity and the state's grid. So they basically have to come in to see that the deficient load, they have to ask some of the generating station who is generating say 180 megawatt out of 210 megawatt capacity, that please increase your load from 180 to 200. But somebody may be asked that because if the load has gone down, that somebody who is inefficient, you please reduce your load from 200 to say 150, something like that. So this is how the load dispatch centers work.
Thank you,
Yeah,
sir.
please.
So, load dispatching involves dispatching of the load from the generator to the load.
Can you also
As
explain what
explained.
information is available in these load dispatch center? As Govil has said, you can totally explain how, something he has explained.
Yes,
But
sir.
then what information is available with them? How do they proceed? That also
Yeah.
you can explain to them.
I'll come to that.
Yeah.
So basically I will first start with load dispatching. Dispatching of load means dispatching of the generation to the load. Load dispatch center constantly observes the grid parameters and tries to maintain the grid parameters. As explained, the load dispatch center has the voltage of each line, the voltages being maintained at each substation, the currents drawn, the frequency maintained in the system, and the harmonics being in the system. So all these parameters are available in real time at the load dispatch center because you have data coming in from all the substations within the region. And whenever, like explained, there is a fall in load or an increase in load, then the generation has to be accordingly increased or decreased. And that function is carried out by the load dispatch center, that which station is to be backed off, which system has to shut down, or where load shedding is to be carried out. That also is being done by the load dispatch center.
Now this real time, she used, Madam using the word real time dispatch. That would mean that somewhere the time element is involved. Now there could be 100 generating stations in a region. A region consists of many states. For example, the eastern region will consist of Bihar, it will consist of Orissa, Sikkim, like that. There would be a set of states. In northern region we have Rajasthan, we have UP, we have Jammu and Kashmir, we have like that. There are a number of groups of states are there. In a group of state there would be more than many generating stations would be there. Then many transmission lines are there. Then we have meters installed at the generating end, we have the meter installed at the receiving end, and there is because there is a measurement. Now real time would mean that there is a time watch connected with that electronic. Now all these timers must have the same time. So they are synchronized through the satellite, and because if suppose a station trips at 5 hours in the morning, and now you want that at 5 hours in the morning or 1 minute past 5, some line should be energized or some another station should be started. Unless there is a synchronization of these watches at different point of time, there could be hundreds. So till such time a real time system will not operate, and it is very necessary, and it is done through the satellite. All these watches are synchronized so that the power transfer at one point of time is recorded, so the another corresponding parameter is recorded at the same point of time. Only then you can achieve a correct function.
The synchronization of the clocks is done through the GPS system, and we have 4 modes of operation for a grid system. One is the normal, when the generation is equal to the load, but then when there is an emergency like some generator backs off or it fails, then we have to do load shedding. So there is an alert that there is some generator is backing off or it is failing. Then we have to have restorative measures for matching the generation as well as the load, and we have to tell the states to back off their loads or do load shedding. So that type of all these modes of operation form a real-time operation. So there could be loss of generation, there could be unit failures. The possible system problems could be insufficient generation, loss of generation, unit failure. There could be a transmission line failure. There could be a loss of load. There could be buses isolated, and all these could result in reduced network redundancy and line overloading. So we may have to carry out islanding to prevent system collapse, because all of these can cause system collapse, and the basic idea of grid operation is that you should prevent system collapse. We hear of grid failing. Sometimes back our western grid failed or our northern grid failed. So we want to prevent such collapses by a smooth operation of the grid, and grid operation means preventing collapse at all costs in the case of loss of generation as well as loss of load.
Can I request Dr. Chandra to explain how the grid collapse occurs? Means, what is the grid collapse? Grid collapse means what? What happens?
Actually, in a grid collapse, some machine trips and the parameters go beyond the desired values. So other machines also start to trip, and there is a cascade tripping of the various generators. And at that time, lot of generation goes off, and therefore there is a grid collapse.
Now, to tackle with such emergencies, now in a system, one station has tripped, and you find that the grid frequency naturally varies. So the operator in charge in the load dispatch center, he has to decide now what is to be done, whether to restart a machine, whether to start to increase generation on one particular machine, or he has to cut off a transmission line, he has to cut off a load to have a balance. Now, which one to be done? He will have several alternatives, that he is feeding the generation to several load centers. Which one he has to decide? One is that by experience he would know that if I open up this circuit breaker, if I open up this line, then perhaps he can save the system. Nowadays the intelligent software systems are available, which would decide, which immediately if there is a load throw off somewhere, some generating station goes off or some line goes off, then it will do an economical study through the software, and it will say one or two alternatives. First priority, you can open up this system. Second priority, if you are unable to do this because of any constraint, then you can increase generation here. So that kind of techno-economic, the least cost options it will give you, so that the operator can easily decide. Such systems are now available, and most of the dispatch centers are using such systems. But then use of such system is useful only when you are not in a shortage era. If you are in a shortage area, perhaps you have no options to decide. But if you have, with time, as I explained to you yesterday, that in another 5 to 7 years period, we will be having surplus capacity in our system, and therefore it is at that point of time that to run such software and to decide most economical load dispatches in the country.
Thank you, sir.
System collapse when we say the system collapse can be prevented by isolation of certain system, as Madam Chandra said, and that isolation means that as soon as the person who is sitting at the desk of the load dispatch center, he finds that one machine has tripped, and because of that another machine has tripped. So he has to immediately isolate certain breakers, which means that the machine which has gone out, accordingly certain amount of load should be removed from the grid. Then only the grid collapse can be achieved. So immediately he has to take a decision that which breaker he has to trip, so that some load will go off but the entire grid will not go down. And when you are having the entire nation connected with the national grid, the chances of the whole nation going down is also there if we do not operate the load dispatch centers in an effective manner.
The best example of this saving and isolation of system was the Calcutta Electric Supply Company, the Eastern Region, Calcutta. Now, Calcutta, in West Bengal, the electricity supply is there from the West Bengal State Electricity Board. Then there is a generator called Calcutta Electric Supply Company. Now, this company has its own distribution system separately. So, whenever any disturbance takes place in the eastern grid, and this CESC and their load dispatch senses this and they isolate themselves, islanding. So, that area gets islanded, and whatever happens to the grid, this supply is not affected here. Their frequency was different. And that is why that in that area where the supply was from the CESC, there never used to be any electricity failure. It was a very stabilized system.
Thank you, sir. So islanding is one of the possibilities for saving the grid. And in a shortage situation, our regional load dispatch center operators, I think, are quite adept at dealing with the emergencies. In fact, when there was a grid collapse in California, then they asked our power grid engineers to come and help them because they did not know what to do in case of a grid collapse, which was very rare there. But here, in a shortage situation, we are faced with these emergencies very frequently, and we know how to deal with them. So the online support systems for dealing with the grid management are, we need a good SCADA system. We need, SCADA means supervisory control and data acquisition system, which means that we have RTUs, remote terminal units, installed at all the substations, which through a communication system send data regarding the various parameters, voltage, power, energy flows, current, power factor, etc. to the load dispatch centers, and we have data of all the substations and transmission lines at a central place. So, and supervisory control means that we can shut off or open the breakers from a remote location. So for this we need motorized breakers, and the operator sitting at the regional load dispatch center can open the breaker of some important transmission lines by himself, sitting in the remotely. Sitting at the regional load dispatch center, he can remotely operate the breakers of the transmission lines. We also have EMS functions at the regional dispatch center, which means energy management systems, like softwares for contingency analysis, steady state load flow studies, and dispatcher training simulator. We also have systems for historical data storage and retrieval at these regional load dispatch centers to help the operator decide what has happened in the past and how he can deal with the emergency which is arising. Offline activities for grid management. These were online or real-time activities, but these are supported by many offline activities for grid management. One is operational planning. Operational planning is done to ensure that generation matches the load at all points of time. So you have to do this planning in advance, and the voltage profile at all points of the grid is within limits. no lines or transformers are overloaded. So you see that what will be the load in ahead of time, and see that no line or the transformer is overloaded. If this happens, then you try and alternative paths for sending the power, and that there are no path swings. Then we do load scheduling and dispatch offline. We schedule for the day ahead, for example, how much load, how much of energy we require for the day ahead. Schedules are generally prepared on a 15-minute basis. And there are financial penalties for violating these schedules. To ensure grid discipline, we have incorporated the availability-based tariff, so that when you overdraw or draw at peak time, then you have to pay for an unscheduled interchange charge, which comes under the availability-based tariff, and the cost of unscheduled interchange is very high as compared to the cost which you would be paying for a scheduled interchange. Scheduled interchange means the schedule you have given to the regional load dispatch center that we want to draw this much tomorrow at this time. So if you are drawing more than that, then according to the availability based tariff, you have to pay much higher, and that charge is called the UI charge, of which you may have heard.
Okay,
and
let me explain, Anjali. This is a availability based tariff system. This system was introduced in the country in the year 1998-99, when we found that the frequency of a region was going beyond tolerable limits. I mean, it used to exceed 52 hertz in some area. It used to go below 47, 48 hertz in some area. And these are very dangerous limits, very unsafe.
Why this was happening? Kindly also tell our learner friends.
Okay. This was happening because, say, in the eastern region was an example of the high frequency. The region was that the state sector has to buy power from the central generator and have to pay for it. And since the eastern region was in the surplus area, they didn't want to buy power. But since there is an agreement that before the central station is set up, you have to agree. You have to pay for this fixed charges of the station. Fixed charges means the capital cost and the O&M cost, etc. And there is a variable charge, the fuel cost. So they would prefer to bear the fixed charge but not pay for the variable charge, because in any case variable charge is to be paid if they have to buy the electricity. So everyone was trying that we will not buy the central power. They will give this schedule. Schedule means we will ask them in advance, what is your demand? Say in this month, every 15 minutes, every hour, what would be your requirement of power? Out of that requirement of power, how much you would like to generate yourself and how much you would like to buy from the central generator. Accordingly, a schedule will be prepared. I mean, if you believe the state generator and that how much they want to generate power and how much power is the requirement from the central generator, accordingly, if the schedule is prepared, we find every time, always, it used to end up in a high frequency area. It means that that much power is not required to be pumped into the system. So if the frequency is high, one is it is dangerous for the appliances, it is dangerous for the generating unit, as well as it is a wastage of fuel. Because if the power is not required, why do we generate that power? So it was becoming inefficient, a very expensive system, extravagant system we can call, that the power is not required to generate it. Still we burn the coal in the generator. So the frequency used to go high.
If permitted, I will add something here. You see, there is a system in which the central government and Central Electricity Authority gives a prize to the thermal stations who are having the highest plant load factors, which means in comparison to their capacity, their generation is the highest. So for that purpose, also everyone who was in a running mode wanted to maximize its generation. And as long as you do not shut down some of these stations, this frequency will keep on going up. So if everybody wants to increase its generation, it will generate electricity, but it is not doing any good to the consumers, because consumers are not getting benefited. Some of them may be getting actually disturbed, because somebody's bulb will go fuse, somebody's motor will get burned, and things like that may happen. So this is what.
So there was a government designed an incentive scheme for the generators. These incentive scheme are basically designed that the country's power stations were operating at low plant load factor. Plant load factor means if it is a some X capacity 100 megawatt plant, then it must generate for 8,760 hours in an year. But then the performance was low because of many reasons, and therefore government devised an incentive scheme. Incentive scheme was becoming a disincentive in the system, that everyone wanted to generate more. So this is how the frequency was going higher. Now in an area where there were deficit of the power, in the northern area, the western area, the southern area, then everybody would like to draw power because they want power. And if the load shedding is not there, the frequency would go to below 47 hertz, 47.5 hertz. This is the number, 47.5 hertz. The generating stations are designed to operate at this frequency for unlimited time. I mean, there is no limit of operation of these plants. But if the frequency goes below 47.5 hertz, then the duration allowed is few seconds or few minutes in its lifetime. Therefore, you must shut down the unit. So low frequency operation would give rise to shutting down of the unit, and maybe it results into the failure of the grid, the cascade failure of the grid. And this kind of a situation was very detrimental to the nuclear power generating stations in the country, because their reactor becomes very sensitive to this frequency, and they cannot vary their generation on the unit off and on like the thermal or a hydro station. Therefore, a problem was there that how to do it. In the load dispatch centers were doing it by telephonic instructions, that frequency is low, please increase your generation. The frequency is going high, why don't you shut down one of the unit? Now who will shut down? The Bihar will say, I will not shut down. The West Bengal will say, why should I shut down? So everyone would not agree to that kind of a instruction, and there was no automatic system existing in the load dispatch center. So it was only by verbal communication, and it depends on then the authority one organization has. The load dispatch center was with the Power Grid Corporation of India, and then the state would think that this is another corporation, why should we listen to them? So some kind of an administrative problem came in controlling the grid. So a system of availability based tariff was designed. Availability based tariff means it is a commercial arrangement that if the frequency in the system is low, you must not draw power. If the frequency is low, you must not draw power. If somebody draws power when the frequency is low, you must pay very high charges for this power. But if the frequency is high, you must not pump the power into the system. If somebody tries to pump power into the system when the frequency is high, it should not be paid for. So there was a system that if the frequency is very high, beyond 51 hertz, then the power was free. The zero money would be paid for that power. So it was both paying higher charges when the frequency is low and paying no charges when the frequency is high. Therefore, the generator who is generating power at a high frequency, naturally he would not generate because the power is not paid for. So a discipline was created into the system, and this was called availability based tariff. Availability based tariff means depending on the availability of your generation, depending on your requirement, a schedule would be prepared. Now whosoever deviates that schedule, it is called unscheduled interchange, UI in brief, it is called unscheduled interchange. So if you deviate the schedule when the frequency is low, then whosoever draws more power, he has to pay high charges. The generator who pumps in power, more power at a time when frequency is low, he gets more money for that. Therefore, it works both ways. And this system is still in vogue today, and that is why you will find that today in the country the frequency band is very reliable. The quality of electricity has gone better, and rarely you will find that the frequency goes below 49 hertz. Sometimes it goes when the distress is there. Even last couple of days I have been observing for a couple of seconds or few minutes the frequency does touch below 49 hertz, but it is not going beyond tolerable limits. That is the advantage of this system.
Thank you, sir.
The other offline application is system studies, and I've just put a small cartoon there, so which says that I have no objection to creative problem solving as long as it is not too creative and it is not a real problem. So system studies help us in creative problem solving to find out which lines are overloaded, which system is getting overloaded, where do we need augmentation of the grid, and which are the alternative paths for allowing the power to travel from the generation to the load. Then metering and settlement is also done offline, like we talked of UI charges. So how much of energy for at the end, at what rate each generator is to be paid, and how much of payment is to be made by the power utilities, that all is done offline. And the data downloading at local stations, data processing at RLDC, energy accounting, how much of losses are to be charged to the utility, which utility is, along the way has how many losses, all this, and raising of bills by central generation and transmission utilities also is done through the RLDC offline.
Offline means you can do the accounting later. But these meters whichever have been installed, they are the real-time meters are there, and they keep on logging the exchange of power flow generated or flowing in a line with time accurately as synchronized through the satellite. And offline means you can go in a month's time and then record, take through the computer, your remote computer terminal, that it will give you all the data, 15 minutes wise data will be there, and then from that data, of course, there
is a call from Mumbai.
Yeah.
Okay.
Yes.
We can take this call. Yes.
I have a question with Verma Sahab.
Yeah, please.
I want to know how the peak rate of UI rate is fixed, and I know there is one petition filed by Power Grid to increase the UI rates. So it is, I think it is up to 9 rupees. Currently the rate is 6 peak rate. So how the rates are decided by CRC? Whether there is need to increase or decrease, and whether there is any relation with the peak power rate of basically the liquid fuel. Liquid fuel rate. I think the comparison is liquid fuel.
If you have finished your question, you see, one is that the highest rate for the unscheduled interchange at the time when the frequency is low is kept to be a deterrent to discourage the people from drawing power from the grid at that point of time. So it is decided that this rate has to be higher. Now, whenever there is a drawal of power, then the additional power, the incremental power comes from the costly sources. The present highest rate is rupees 570 paisa, 5 rupees 70 paisa for the highest rate is there. But then this rate is, we felt that this is perhaps not helping us, because whenever the frequency is low, some of the states draw more power in excess of their schedule, and then it disturbs the grid frequency. So there has been a thinking that this rate must be increased. More so because this rate became not very relevant, because now we are generating power from the naphtha. Naphtha is a fuel which is very expensive, and then diesel is still more expensive. The paper which you are referring to from the CRC, which is on the website for the comments, the rate is proposed to be increased to 7 rupees 45 paisa. This is the rate of generation of power from the naphtha as a fuel, liquid fuel. We have still not gone for diesel, because diesel is very expensive and the diesel power is not much available in the country. There are many stations in the country, especially the combined cycle gas-fired power stations, which can run on dual fuel, and sometimes one of the station is only firing this naphtha as a fuel. So we thought that it is appropriate if at least the cost of generation from the naphtha is covered in this highest UI rate. So the present proposal is based on 7 rupees 45 paisa. Some of the members or some of the people are feeling, my personal view is also that if you have to maintain a grid discipline strictly and must maintain the grid cycle as 50 hertz in the country, then this UI rate must be increased to a very high value. I would recommend even 100 rupees per unit rather than 7 rupees 45 paisa or 5 rupees 75 paisa. Only then the somebody will feel a pinch of drawing more power in the grid and maintaining their stations to at a high level of performance.
Yes, of course.
In some of the countries, this rate is $1,000 per unit.
With the permission of Mr. Verma, I would like to make a
Yes,
small
you may have a
comment on
different
this.
opinion, of course.
I would like to make a comment on this aspect. The UI rate, there is no way of determining the UI rate, as Mr. Verma has explained, that because this is basically a rate which is to create a deterrence among the users of electricity, who should know that they should not utilize the electricity when they have not told its demand earlier, and when the grid capacity, the generation capacity in the country is limited. Because as you know that we are already facing a shortage of energy, so if in the peak situation somebody overdraws, then he is basically creating a disturbance in the system and he has to pay very highly. But how to decide this is a question which how it has been decided, Mr. Verma has told, but how should we look at it means for the future and how the planners and administrators may look at it, I would like to suggest to my learner friends. You see, one is anybody who is trying to use electricity, he may be prepared to pay a price for it. And sometimes it has been reflected by the price at which some of the states have brought power through trading, because trading is also an activity in the new Electricity Act. So one of the parameters which may determine this UI exchange rate is the maximum price which any of the state is willing to purchase electricity to satisfy its customer. The second is the highest cost of generation, which means that the marginal cost of generation, the station which is being added to the grid at rate you charge. And I feel that this is the best way of deciding, because UI rate should not be made anything just for the sake of deterrence. Any additional unit which is to be pumped into the system in order to meet the demand. If we are operating in the system where the average cost of generation is X, and if we have to add another unit into that, and that cost of generation of that unit which is to supply the incremental demand, if the cost of generation is Y, then that is the price which the UI should be allowed at.
Dr. Govil, it was okay.
Another point after that. Another point is that if our generating stations are all fixed with a system of increasing or decreasing the generation depending on the frequency, and if our connected load is also having a technological intervention of shutting off the power when the load is increased beyond a particular level, then perhaps there will be no demand of this UI rate for controlling the grid frequency and grid management. This is what my suggestion is.
So you may be right in a system when an incremental generation, if it is feasible to pump into the system. We do not have. At the moment, this system of the availability based tariff would be working till we have shortage situation. And if the shortages are not there, your suggestion that free governor mode of operation on the units must be implemented, then that would solve all the problems. But then if you have to make it deterrent in a situation when someone should not be putting the whole grid into a danger of the grid failure, then this rate has to be deterrent. And this deterrent rate then cannot, I agree with you, then there cannot be a basis at that point of time. You have to see when it becomes, when the people feel that yes, it is deterrent. It depends on their paying capacity of the state, because state has to buy power. If the state feels that at the present rate 5 rupees 70 paisa is not deterring them actually, and they are free to overdraw power from the grid and put the grid into a dangerous situation, then we must increase this rate. And so it depends on how I have explained that what has been the basis. Now we have to have some basis. We cannot put an arbitrary number that put this number, if it is not 50 rupees, let us make it 100 rupees or something. At the moment it is based on the naphtha as a fuel. There was a suggestion that put it diesel may be around 9 to 10 rupees. It would become furthermore deterrent. So after this rate is accepted and we receive comments from all the people, all stakeholders, perhaps their decision would be taken on this. And then suppose that also doesn't solve the problem, then maybe that needs to be reviewed. Thank you.
Thank you, sir. Another activity which is done offline is preparation of daily reports and periodic reports. The daily reports which are prepared are regional power supply position, outage status, frequency analysis and trends, voltage analysis and trends, schedule versus actual role of states, and periodic reports are also prepared weekly, quarterly and annually on the power supply position as well as the schedule versus role of the states. So these types of reports are prepared to take informed decisions later on for managing the grid. Thank you.
Thank you, madam. We come to the end of this session. Really, we had very good and interesting discussions. Thank you to my experts here, and certainly learners must have been benefited by these discussions. So we will have a short break of 10 minutes. We will assemble here at 12:10 again. So till then, goodbye. Thank you.